Good morning, ladies and gentlemen. Today we're going to do a video that shows how to mount the muscle chuck on a standard router so that we can minimize runout. The problem is the fact that we're trying to mount two solid cones against each other. The reason that you get away with that, no runout with the collet, is the collet is flexible. The muscle chuck is not. So you have to fiddle around with it a little bit to get it mounted properly and not cocked in the spindle, or sitting on a high spot in the spindle, which we'll explain later on in the video. You'll see here next to me I have a standard 690 Porter Cable router. It's one of our most best-selling chucks, and we're going to mount a muscle chuck on it, and we're going to randomly mount it and show you how bad the runout is, and then we're going to find what I call the sweet spot. In other words, when the cones are actually seated against each other, that's where you have minimum runout. But the very first thing that you should do before you try to do anything is you should try to measure the runout of the spindle itself. The routers are not perfect. They're ground and mass quantities. There are high and low spots in the spindle, which we'll address a little bit later. And you know, if you try to mount something solid in there, chances are it's going to not be collinear with the axis of the spindle. What I mean by that is the axis of the chuck and the axis of the spindle will not be lined up on top of each other perfectly. You'll notice to my left also on the surface plate we have a very expensive, high accuracy 10,000th reading dial indicator, which will go in each direction, as you can see, and we're going to use that to make our measurements. What we do is we'll put the router motor against the surface plate, and then we'll adjust the dial indicator such that it'll make contact with some part of the router taper inside the spindle. So you see we'll come up on it and we'll lock it into position. Okay, and let's rotate the spindle to see. Let's set the 0 so it's easy to read. Okay, we're sitting on 0, and let's rotate the. You can see how we have about we have just about 1,000th, maybe 9/10 of a 1,000th run out on the spindle. Okay. Okay, so now we know we're dealing with 1,000th run out with the spindle itself. So now we will remove the dial indicator and we will mount the muscle chuck. And that simply screws on to the spindle as such, and we tighten it down. About 1/4 of a turn, that's plenty. And we'll mount a real cutter that we have, a piece of plastic over the end so we don't cut ourselves, into the muscle chuck. And once again, we'll put it in there, and you can see that the air is holding it up. It's very good fit, very good finish. And then what we'll do is we'll snug the cap screw down till it's just snug, and then we'll do 1/4 of a turn, and that'll put just about 95 to 100 inch-pounds of torque on the cap screw, which is translates to about 40 foot-pounds of breakaway torque on the tool. So the chances are you'd stall the router before the tool would slip. Okay, again we bring it to the surface plate and mount it against the surface plate, and we have to readjust the dial indicator so that okay, we're on the axis now. We'll readjust the 0. And we can rotate it very, very gently to see what the runout is. Okay, looks like we're going about little over 2/1000ths to the left of the zero and approximately 1/1000 or so to the right. So that's about 3.5 thousandths. So that means the muscle chuck has introduced about 2.5 thousandths of run out. So what we'll do at this point is we'll put a mark on the muscle chuck. Actually, you could use the balance hole if you really want to. And we'll put a mark on the spindle. That's where we're starting, okay? So now what we do is we very simply loosen the muscle chuck. And we'll rotate it about 1/4 of a turn is a good place to start. And again, snug the nut down and then go ahead and tighten it 1/4 of a turn to that like that. Again, we go back to the surface plate and we readjust the zero. Okay, and then very gently turn it and see how we did. Now it looks like we did worse. It's 3/1000ths on one side and 2.5 on the other, so we've increased from 3.5 to 5.5. So what does that tell us? That tells us that we are going in the wrong direction as far as trying to line the chuck up. So what we do is, once again, we loosen the chuck. There we go. And remember, we're using the balance hole and this particular flat. So we go back 1/4 of a turn in the other direction. And we snug the nut down. And then 1/4 of a turn, again to the surface plate, and we will adjust and rotate very gently. My goodness, look at that. How about that? Looks like we're going 1/4 of a thousandth past zero on the one side and about 3/4 on the other side, which means that we have a total run out of 1/1000th of an inch, which just happens to be the run out of the spindle itself. So you now have the muscle chuck mounted in the router as best as you're going to do. So you've eliminated all the run out that the muscle chuck will introduce. The next thing is the vibration, so we will crank it on. See, at 24,000 RPMs and a rather typical type cutter hanging out of the chuck about 1.5 to 2 inches, you have very little vibration, if any at all. So at this point, we're going to conclude this particular video. We appreciate you watching the video, and we thank you for your interest in our product.